Hi students, welcome to my class. Under Geography, I'll be discussing about igneous rocks and their formation. In the earlier lecture, we have understood what is a rock and how rocks are formed. The outline of my today's lecture is igneous rocks and their formation, types of igneous rocks, and their economic significance. The learning outcomes are, at the end of the session, students will be able to explain how igneous rocks are formed. They'll be able to identify igneous rocks, classify igneous rocks, and appreciate their economic significance. Igneous rocks are born due to solidification of molten material of the Earth's crust at a depth ranging from 16 kilometers to 20 kilometers in the molten form known as magma. Igneous rocks are called as primary rocks. They are the first rocks that are born on the Earth when Earth was cooling down. Hence, once upon a time, the entire Earth was covered by primary rocks, that is, the igneous rocks. Igneous rocks have their own characteristic features. The first important characteristic feature of igneous rock is the magmatic consolidation. So, as it is said earlier, that igneous rocks are born due to solidification of lava. Therefore, in every igneous rock, we find magmatic consolidation. Igneous rocks are both crystalline and non-crystalline. This is the second important characteristic feature of igneous rocks. All igneous rocks are non-porous. When we immerse an igneous rock, it doesn't absorb water. Or when we put drops of water on a rock, the water doesn't penetrate through rock because the igneous rocks are non-porous in nature. Since igneous rocks are very hard, they are not easy to be eroded. You require lot of time, you require different weather conditions to erode an igneous rock. All the igneous rocks contain high silica. It ranges between 40% to 80%. These are very important characteristics of igneous rock, which are found in different parts of the world. Let us look at the types of igneous rocks. Broadly, we divide igneous rocks into two types, namely extrusive igneous rocks and intrusive igneous rocks. Extrusive igneous rocks are those rocks which are born due to solidification of lava on the surface of the Earth. Meaning, the magma, the lava comes outside the surface and cools and solidifies. Rocks born out of such solidification are called extrusive igneous rocks. Whereas on the other hand, when magma doesn't come out, it remains inside and gets solidified. Such igneous rocks are known as intrusive igneous rocks. Let's have a look at this video, and from this video we will understand how extrusive igneous rocks are formed. Granite is intrusive igneous rock. This particular rock is born inside due to solidification of lava inside the earth, as a result of which the cooling of granite is very slow. Therefore, the crystals in a granite are of a very large size. You can see the crystals. Similarly, basalt is an extrusive igneous rock. So this entire hill is made up of basalt. It is composed of basalt. Basalt is a dark colored rock. This rock is born as a result of the solidification of lava on the surface of the earth. Basalt is the best example. In this basalt, the crystals are very small, very small, because the solidification of rock is very fast. Whereas in the intrusive igneous rock, solidification is very slow, and that results into large crystals. And in extrusive igneous rock, solidification is slow, it results into very small crystals. Gabbro is another example of igneous rock. Let's look at other igneous rocks. Laccoliths. Laccoliths are those rocks where the content of silica is very high. For example, dolerite. So normally silica ranges anything between 40% to 80%. So here the content is very high. So such rocks are called laccoliths. Then we have batholith and stocks. When the molten magma accumulates in a wide area in such a way that its accumulation cuts across many layers, it is known as batholiths. Whereas smaller deposits are called stocks. Next igneous rock is lapoliths. When batholiths are deposited in a concave form, so you can see here inside the crust you find the deposition like a concave. So this concave shape of deposition is called as lapolith. Then we have pacholiths. When magma is deposited in a wave-like form, so you can find so many waves here. So when magma looks like waves inside, such igneous rocks are called as pacholiths. Then comes the sills. The solidification of magma inside the crust occurs in a horizontal manner. So we can see this is how horizontally magma solidification has taken place. Such horizontal solidification or cooling of magma is called as sills. Then you have a dike. In a dike, solidification of magma is like a wall, meaning it's vertical. If it is horizontal, it is called sill. If it is vertical, it is called a dike. So here you can see one rock which goes deeper inside like a wall. So now here you can see the rock dark colored which is at the center is a dike, and on either side you find gneiss. So here is a gneiss, here is a gneiss, and in between through a crack magma has come and got solidified. So this dark colored rock is a dike. This is same. So you have here intrusion of dike into gneiss. So the rock here and the rock here is gneiss, and in between you find the intrusion of dikes. This is also intrusion of dike into gneiss, and also you find here intrusion of dike into granite also. This is also a very beautiful picture of dike. Dike extending deeper into the Arabian Sea. Now look at the economic significance of igneous rocks. The metal ores which are important for industry, they are all basically originate from igneous rocks. So therefore, for industry, igneous rocks are very important. Magnetic iron, nickel, copper, zinc, lead, bromide, manganese, gold, diamond and platinum are all associated with igneous rocks, and they have a great economic value. Old rocks of the great Indian peninsula are rich in these crystallized minerals and metals. Rocks such as granite are used as building material, and they also have a very high economic value. Thank you very much for listening to my lecture.